Good day everyone, I am Eujanefaith Maure of Group 2 from E11H, and today we'll be discussing about discrete and continuous random variables. So first, what is random variable? Random variables are properly described as functions that assign a real number to each element of the sample space. To simplify, random variables are numbers whose value is random. There are two types of random variables. These are the discrete random variable and continuous random variable. The first type is discrete random variable. A random variable is called discrete when it is countable and has no values in between. An example of discrete random variable is the customer count. It is because there is no such thing as 1.5 customers because you can't divide a value of a person into half. The second type of random variable is continuous random variable. You can call it a continuous random variable when it takes on a countable number of possible values.
Discrete probability distribution and its properties. Example, there are 4 different outcomes in picking 2 shoes out of the 4. Blue, 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 pink, pink, blue, and pink, pink. Letter X be the random variable which will represent the number of our blue shoes picked. Values of X, 2, 1, 0. Number of times it occurred in sample space, 1, 2, and 1. Thus the possible values of the random variable X are 0, 1, and 2. Example number 2. In a rolling die, there are 6 possible outcomes which corresponds to one of the sides. So 1, there will be 1, 2, 3, 4, 5, 6. And the frequency of it if we roll the die once will be 1. Thus the possible outcomes for the random variable Y are 1, 2, 3, 4, 5, and 6. Properties of probability distribution. The probability must be between 0 and 1 and their sum should be equal to 1. Example, the probabilities 0, 0, 1, 0 are between 0 and 1, which means that 0 and 1 can be values of the probability. If we add them, their sum will be 1. Therefore, the given table is a probability distribution. Another example, 0.25, 0.01, and so on and so forth. The probabilities are between 0 and 1, but if we add them, their sum will be 1.03. Since the sum of the second property is not equal to 1, this table is not a probability distribution.
How to find the mean, variance, and standard deviation of a probability distribution are given. Note that x and px will always be a given. Our first step is find the mean. In order to find the mean, we need to multiply x to px. 2 times 0.1 equals 0.2. 3 times 0.2 equals 0.6. And after we get all of our products, we will just add them in order to get our mean. Thus, our mean is 5.3. Our second step, find the variance. Note that we will use our mean, which is 5.3 here. 2 minus 5.3 equals negative 3.3. 3 minus 5.3 equals negative 2.3. After that, we will proceed to the fifth column. We will just need to square root our answers here. Negative 3.3 squared equals 10.89. Negative 2.3 squared equals 5.29. After that, we will proceed to the last column. We will just multiply all of our answers here to the px. 10.89 times 0.1 equals 1.089. 5.29 times 0.2 equals 1.058. And after that, we will just add all of our answers here to the last column in order to get our variance, which is 6.01. Therefore, our variance is 6.01. Our third and last step, find the standard deviation. In order to find the standard deviation, we will just square root our variance. Thus, our variance is 2.45.
The normal curve and its properties. A normal distribution, sometimes called the bell curve, is a distribution that occurs naturally in many situations. For example, the bell curve is seen in tests like SAT and GRE. The bulk of students will get an average score of C, while smaller students will get an underscore of a B or a D. an even smaller percentage of students might get a score of an F or an A. This creates a distribution that resembles a bell, hence the nickname. The bell curve is symmetrical. Half of the data will fall to the left of the mean, half will fall to the right. Many groups follow this type of pattern. That's why it's widely used in business, statistics, and in government bodies like the FDA. Heights of people, measurement errors, blood pressures, points of test, IQ scores, and salaries. Properties of a normal distribution. The mean, mode, and median are all equal. The curve is symmetric at the center. Exactly half of the values are to the left of the center and exactly half of the values are to the right. The total under the curve is 1.
Converting from normal distribution to standard normal distribution and vice versa. Any point from a normal distribution can be converted to the standard normal distribution with the formula Z. X means standard deviation. Z for any particular X value shows how many standard deviation X is away from the mean for all X values. And these are examples of converting normal distribution to standard normal distribution and vice versa. Find the Z-score of the data value 98 for a population having a mean of 80 and a standard deviation of 8. In this time, we're going to find Z, and the formula of Z-score is, say, X sample space mean divided by standard deviation, and Z98 minus 90 divided by 8. The Z-score is 2.25. Find the Z-score of the data value 93.1 for a population having a mean 73.5 and a standard deviation of 13.2. Like number 1, we are going to find Z, so we are use of formula of Z-score. Z equals 93.1 minus 73.5 divided by 19.2. The Z-score is 1.48.
Areas under the normal curve. The curve or graph of a normal distribution is symmetrical. We can use this graph to determine the area of the following z-scores: 1, 2, 3, -1, -2, and -3. So what is the area between -2 and +2? The answer is 95.44%. We can also determine its area by adding the values in the middle. But what if the given z-score is not among the z-scores that I have previously mentioned? The answer is, use a z-table. The z-table that we will use will depend on the sign of the z-score. The areas in these z-tables refer to the area below or to the left of the z-score. So if the question is asking for the area above the z-score, we will just subtract 1 with the area below the z-score. So this is the answer.